Alright, so today we're going to look at a unit of concentration called molarity. Remember, concentration is the amount of solute that can dissolve in some amount of solvent, and that is how we can quantitatively describe. When we talked about solubility curves, we were qualitatively describing them. So here we're quantitatively describing the concentration of a solution. So the formula for molarity, which can be found in your reference packet, is we use this capital M for molarity, and it is the number of moles of solute divided by liters of solution. Okay. Alright, so let's look at a problem. What is the molarity of a solution? So we're looking for the molarity made by dissolving 3 grams of sodium chloride in 1 liter of solution. Well, since by definition we have our molarity as moles of solute per liter of solution, then we need to figure out how many moles 3 grams are. So I have 3 grams of sodium chloride. I need to convert that first to moles. So 1 mole of sodium chloride has, we add those up, 58.44 grams in 1 mole. And then we divide. And we get 0.051 moles of sodium chloride. And then for our molarity calculation, we plug in our moles, 0.051 moles, divide by our liter of solution, and we get that our molarity is 0.051, and we use this capital M for our unit. You can also use moles per liter, since that's what we have, but the capital M also means moles per liter. Alright, so next one, it says what mass of potassium nitrate is needed to make a 2.5 liter of a 0.25 molar solution. Now remember, we describe mass in terms of grams, but our equation uses moles. So first we have to get moles, and then we can convert to grams. So this is kind of a backwards problem from number 1. So let's plug into our equation. We have 0.25 is our molarity. That is equal to our X number of moles divided by 2.5 liters. So to solve for X, we cross multiply. And we find that X is equal to 0.625 moles. Again, that's potassium nitrate. So then we want to convert that into grams. So 1 mole of potassium nitrate goes on the bottom, and then the mass from the periodic table of potassium nitrate on the top. And that mass, as we look up those on the periodic table and add them together, is 101.11. Then we multiply across the top, divide by the bottom, and we get 63 grams of potassium nitrate. Now I kept 2 significant figures because both of these numbers here have 2 significant figures. Alright, so at this point you should pause and try the practice problems on your own, and then you can come back and check to see if you got them right. Alright, welcome back. We're going to look at these problems together. So here we have 0.5 moles of sodium chloride is dissolved to make a 0.05 liters of solution. We want to know what is the molarity. So the molarity is the number of moles, which is 0.5, over the number of liters, which is 0.05. And we divide 0.5 by 0.05, and we get a 10 molar solution. And that is 1 significant figure, since both of these are 1 significant figure. Alright, so then we have 0.5 grams of sodium chloride. Again, our formula for molarity has mole, so we need to convert this into moles first. So our 1 mole of sodium chloride We did this problem previously at 58.44 grams. And if we divide, we get 0.0086 moles of sodium chloride. Now, we have one significant figure each here, but we'll worry about that when we find our final answer. So we're going to find our molarity is equal to our moles, 0.0086, divided by our liters of solution, which is 0.05. And then to our one significant figure, we get 0.2 molar. Alright, so the next one, we have 0.5 grams of sodium chloride dissolved in 0.05 milliliters of solution. So since this is the same mass as we did in number 2, our moles are the same, and so that's 0.0086 moles of sodium chloride. To find our molarity, we need to divide by, remember, liters of solution. So our 0.05 milliliters becomes how many liters? If you recall, there are 1,000 milliliters for 1 liter. So this is a very small amount of liters. So 0.05 divided by 1,000 gives us 5 times 10 to the minus 5 liters. And so we plug that in here, and then we solve. And we get 172 molar, but again we have one significant figure each here, and so we round that to 200 molar, which would of course be a very, very concentrated solution. Alright, so number 4, we have 734 grams of lithium sulfate dissolved to make 2,500 milliliters of solution. So again, we're starting with grams, but our equation uses moles, so we have to convert. And so we're going to need our formula for lithium sulfate. So lithium is in group 1, plus 1, and sulfate is SO4 with a minus 2, so I'm going to need it to have a 2 here. Alright, so we can convert our grams, 734 grams of lithium sulfate, into moles. 1 mole of lithium sulfate has how many grams? So we add those up. And we get 109.952 gram lithium sulfate. Then we divide 734 by that, and we get 6.68 moles of lithium sulfate. So now we can plug that into our molarity equation, our 6.68 moles, and we divide that by our volume, but it has to be in liters. So remember, we want to divide that by 1,000, and so we get 2.5 liters. So we divide, and our molarity, we get, so this has 3 significant figures, that has 2. So our answer, we keep it 2, and I get 2.7 molar. Now, this m is our variable in our formula, our equation. This m is our unit. Again, you can use the capital M, or you can also write the unit as moles per liter. Either one is acceptable. Okay? So when we meet again, we will be practicing molarity.